very broad view. Our next speaker is Dr. Anita Goel. She's the founder and chairman and CEO of a company called Nanobiosym in Cambridge, Massachusetts. Again, a very unusual person, a PhD in physics and an MD from Harvard, MIT as well. And she's been named as one of the world's top 35 science and technology innovators. That was when she was under the age of 35. Anita?
Thank you very much, Bruce. Chairman Omi and my fellow global citizens, it's indeed a pleasure and honor to be here today and share with you some of my own thoughts and perspectives on this very important question of what's happening to healthcare. I believe that in order to truly tackle the challenges of today in global health in both industrialized and developing world nations, we need to be open to fundamental paradigm shifts in our thinking and our worldview. I think the greatest scientific breakthroughs of the last century happened in reductionistic silos. And I'd like to argue that today, the greatest scientific insights, technological breakthroughs, and the new disruptive industries and the transformational approaches to the problems of today are going to happen at the convergence of these conventional disciplines. And so we really need to be able to shift our consciousness to a more holistic worldview that enables us to transcend some of these conventional boundaries between different fields of science and technology, between academia and industry, and even beyond geopolitical borders. My organization, Nanobiosym, was created with that vision of creating innovation on three fundamental levels: science and technology, incubating that where different fields meet, commercializing that, bringing it to commercial scale, some of these innovations, and then focusing on how to maximize the global humanitarian impact that these technologies can have in both developed and developing world markets. Over 25 years ago, I fell in love with physics and mathematics on one end, and the problems of biology and medicine on the other hand. However, the deeper I went in my academic work in both physics on one hand and medicine on the other hand, the more I began to appreciate how disjointed these two fields of endeavor were. Modern physics was really the physics of the last century that hadn't come to terms with things like life, living systems, things like consciousness, and medicine and biomedicine was practiced chiefly at the level of chemistry and molecular biology. Very little was understood about how things like physics play a fundamental role in physiological processes, things like mechanical forces, electromagnetic fields. So I was possessed or inspired, or whatever the word is, with this conviction that the same laws of mathematics and physics that we use to understand the far reaches of the universe should be applicable to understand the mysteries of life and living systems around us. And it was through nanotechnology that I found sort of a practical bridge to bring the worlds of physics and biomedicine closer together. And it provided a way to sort of bring hardcore physics and mathematical tools to bear on biological problems on very, very small scales. And over the past several years at Nanobiosym, our work has started to yield new insights into, for example, nanomachines that read and write information in DNA, and how by controlling several knobs in the environment, you can really control that process, improve the precision and accuracy with which you read and write information in DNA. And we've also developed out of that a commercial product platform called Gene Radar, which enables you to take a drop of blood or saliva, stick it into a nanochip, insert it into a mobile device, and rapidly diagnose what kind of disease a person has. And we're very interested in bringing this to scale in both developed and developing world nations in a way that really maximizes the humanitarian impact that such a technology can have. And just to answer Bruce's initial question on the panel, I think again, it's about taking these technologies and scaling them with a holistic worldview that we can simultaneously attack the problems of industrialized nations and developing world nations. So these are some of the trends I see in the industrialized nations and how technologies like the ones being harnessed from physics and nanotech tools can enable some of the paradigm shifts that are going to happen in healthcare in industrialized nations as well as developing world nations. So in industrialized nations, I see a few trends. The trend towards personalizing medicine based on personalized genomic signatures, you mentioned companion diagnostics, think technologies like gene radar help to enable that, because based on the DNA, RNA signatures, you can now customize your therapies and you can customize your approach to treatments. Another trend is mobilizing medicine, getting rid of the traditional overhead infrastructure, the time, the cost that it takes to go from the presentation of the disease to the diagnosis of the disease, bringing that out into the field, mobilizing it, and really lowering not only the cost of healthcare and that whole supply chain alliance, which in developed world nations is multi-trillion-dollar budgets, really cutting a lot of that infrastructure out. But also empowering the consumer to take ownership over their own health. Today, if you go to a fancy hospital, let's say at one of the Harvard medical hospitals, you are in a highly over-specialized system where you, as a patient, are subjected to multiple specialties. As technologies advance to mobilizing medicine and start to integrate it, we start to make the paradigm shift again to looking at the patient as a whole, where you take control over your own health, and different specialists in the medical healthcare system become like consultants who enable you to do a better job in managing your own health. I think another trend in industrialized nations is going to be wellness. As we get away from just crisis management of diseases and we get into preventive medicine, there's going to be an increased trend towards improving our wellness as human beings and maximizing our performance as individuals, as nations, and as global citizens. And so I think there's going to be these tools will help to promote higher degrees of wellness, not just disease management. In the developing world, I think we can simultaneously bring these kinds of technologies and approaches to attack the problems of the day. Number one, by increasing access worldwide, lowering the cost and the overhead infrastructure requirements that are needed to perform diagnosis. Number two, I think we can really help to create quantum leaps. And a good paradigm, a good example of this is the advent of cell phones. Just like we saw a paradigm shift in the telecom industry when communications and computing devices became portable, we think we can create a similar paradigm shift in the coming years in healthcare by taking the ability of diagnosing disease and taking it outside of a hospital or a pathology lab, bringing it out to the patient's bedsides, doctor's offices, people's homes, and even rural remote villages in the developing world. And just like governments and NGOs would have to invest billions of dollars of infrastructure to create the necessary ecosystem to deliver first-class healthcare in some of these developing world countries, equivalent to sort of having to invest to create landlines in the telecom era, we think we can create that quantum leap or leapfrog over that by having these countries spending a few millions of dollars to adopt some of these leapfrogging technologies, and really helping them to leapfrog the lack of infrastructure and drive overnight access to some of the most advanced capabilities that are available on the planet. And I'd like to close by saying that it's not enough to have a disruptive technology. It's really it takes two things. It takes a consciousness with how we deploy that technology, and it takes an ecosystem of public and private sector interests working together. So we've started something called the Nanobiosym Global Initiative in an effort to form these public-private partnerships with governments, NGOs, public sector and private sector organizations to help bring emerging technologies like gene radar into emerging markets in a way that maximizes its global humanitarian impact, keeps the cost affordable, and drives access to as many people as possible. And I think one of the challenges we find is that in this complex landscape, the financial engineering can be as complex, if not more complex, than the physics and the nanotechnology type of engineering, because you have to really incentivize the entire supply chain alliance to adopt new technologies that may be disruptive to the economic, socioeconomic models of the past. And so I would be interested in this panel and this audience's thoughts on how, as we engineer the healthcare systems of the future, how do we bring the entire ecosystem to work together? And I think this audience is a wonderful collection of academics, business leaders, and policy and government leaders who really are the right leaders around the world to come together and bring the elements necessary to create and engineer this ecosystem and create these changes on a global scale. Thank you very much.
Thank you, Anita. Well, we're finished with our formal presentations. I'd like to, before asking others to come up, just ask a few questions of our panelists. Just continuing on Michael's theme of global health. Anita, you mentioned this one drop of blood diagnostic that you're trying to lower the cost of and eventually, I suppose, use in the developing world. I guess my question was, what kind of cost could you imagine in the future for such devices, and how might them be used, and would they be connected to cell phones, et cetera? And finally, once we drop the cost for the developing world and use it there, can you see it coming back and being used in the United States and other countries that are industrialized?
Do you want me to answer that first?
Okay.
Yeah. So we have first-generation prototypes of our gene radar system that, after we scale up, we're anticipating the cost of, for example, an HIV PCR test, which today in the developed world can range from $100 to $300 a test and take a week or two to get the answers, would come down to $2 to $3 per test, and you get the answer within an hour with generation 1. The underlying technologies could be further tweaked to cut down that time and cost, but the first generation that we're commercializing is set at that sort of target benchmark. And we're also looking at new business models where we can simultaneously launch that in the developing world and the developed world, because in industrialized nations, there's a real need for companion diagnostics, personalizing medicine, which this technology becomes enabling for. So you can now start to customize chips based on DNA, RNA markers that then handshake with, say, a pharma company's drug development program and help them through the FDA process. And so we're looking at ways in which you can simultaneously bring this to the developed and the developing world in terms of a technology platform.
Thank you. Please introduce yourself and before you talk.
Hi, Bruce. Roger Beachy from the Donald Danforth Plant Science Center and former other things. I have two questions. One, the elephant in the room here that wasn't addressed, and I'm disappointed, was health as related to nutrition. And why the linkage between food, agriculture, nutrition, and well-being is not better made, given the links that medicine and public health officials have told us about. So that's one question. Why are we avoiding nutrition here? And secondly, I'd like to see the link, Dr. Drake, between poverty and education that leads to poverty alleviation and the impact of poverty on accessibility to healthcare as well as to better diets. So those are two questions that are really seeks to take that information and see what the consequences of the education are. So there's the nutrition piece and there's the education piece.
Who would like to tackle either of those questions?
I can
Anita?
make some comments. I think the nutrition question is very interesting in promoting not only disease management but wellness. And there is a new field developing of nutrigenomics, which starts to then tie a genomic signature of a particular person with, for example, a diet that they will respond better to. So as our understanding and technologies advance, I think we, again, start to empower people to start managing not just, I think the secret is going to be in empowering people rather than the healthcare system, because you know, there are all these diet fads and everything, but if individual consumers drive that trend towards higher awareness of nutrition and diet and exercise and those lifestyle management as a way of managing their own health, I think we'll get the maximum impact on society. So that's the nutrition question. Maybe Michael can take that.
Please introduce
I'm
yourself.
Henry Dinochkiwe from Zimbabwe. I'm Minister of Science and Technology there. I would like to ask a question on nanotechnology. Maybe Dr. Goel or any other of the panelists can respond to this. But just as a background to it, I want to remind members that major advances that have been done in biotechnology, for instance, the use of various crops, somehow have failed to be effective, particularly in developing countries, because of politicization. All of a sudden, people say they are risky, they might impact negatively on the environment, without genuine consideration of the actual scientific facts. I want to think of what could happen to nanotechnology, particularly nanomedicine. What are the security aspects of usage of nano drugs? Some say the fact that you can send a very small, minute thing through any part of the body, it means that item can linger even to your brain cells and affect you health-wise. So just some comment on the health side of nanomedicine. I thank you.
You want to say anything?
Yeah.
Okay, go ahead.
Oh.
Why don't you go first?
Okay.
Yeah. No, Andreas. Sorry.
Let me try to answer the question about nanotechnology in medicine in saying that I do not believe that today we are able to really address all the safety as well as efficacy questions. And the prime target of nanotechnology approaches in medicine in terms of treatment are with the idea of targeting more precisely. And I do believe that before we really see something coming to broader application to the market, we need to understand much more about the interplay between toxicological effects or unwanted effects and the real efficacy. I do not believe that today we are already there, that we can say tomorrow we are going to apply nano medicines or nano particles widely. But the chance of getting to much more individualized therapies, thinking in terms of tumors, I think you mentioned part of it, you mentioned diagnostics. I think that's a promise where innovation is probably really good science in academic fields. But I would warn ourselves to believe that this is something to come tomorrow. I think it will take much longer.
Anita?
So I would say that I'd like to first define what I think nanotechnology is. It's not just nanoparticles or drug delivery tools, which I agree with what he said. However, so I think nanotechnology, at least in my mind, is the ability to probe and control matter, energy, and systems on very, very small scales, 10 to the minus 9 meter and smaller. And why is that important? Because when you can control matter and systems on very, very small scales, you can have profound advantages in terms of performance that can happen on macroscopic scales. So for example, in our gene radar system, by controlling DNA molecules on very, very small scales, we can improve the precision and accuracy with which we read and write or diagnose the information stored in the DNA. So that does not create a toxic effect on the body. On the other hand, nanoparticles or nanomaterials that are very, very small, that can penetrate your skin pores and membranes, start to create, as you said, new challenges in terms of what does this mean in terms of toxicology. They may be more efficacious in delivering certain drugs to certain target tissues, but then they may open up a whole host of toxicology questions that haven't been examined. So summary answer is that nanotechnology is broader than just nanomaterials. And I agree that in nanomaterials, that's one area in the treatment industry where we have to be very careful about, especially when it's invasive, what the toxic effects are, and the whole regulatory approach that needs to be applied to that. However, in the area of using nanotechnology for personalizing medicine and companion diagnostics, I think there the technologies are already at a level where we can start to use that to inform. I mean, there a lot is known about the human genome. Now these technologies create a platform to rapidly and accurately assess the genome of a person in administering the therapy. And I think this can be done proactively. You don't have to wait several years for the data to amass. You can start creating the data in real time as it's like the internet. It's an open system. The internet grew even after Google started the search engine, and content grew with time. So I think we need to start thinking in terms of open innovation in healthcare, where these platforms really, when unleashed into the market, allow consumers and individuals to become a part of the change in the healthcare system. Thank you.
Would any of you care to comment on...
Sylvia, you have to introduce yourself.
I'm sorry, Sylvia Earle, oceanographer, explorer in residence, National Geographic. Would any of you care to comment on the impact of the declining state of the environmental health on the future of human health? This means air, water, the diversity of life, the character of the planet as a whole, especially the correlation between human impacts on the environmental health and the future of us, our species, our health going forward.
Thank you. Who would like to tackle that? Michael,
Maybe
go ahead.
I think they're all connected. I think it's all the same thing. I think we're really one planet. And one of the problems that we have when we're speaking of global health, one of the things I was sort of suggesting at the beginning is if we can try and compartmentalize health as something in and of itself or by itself, then we're doomed to fail. We're chasing our own tail. And maybe we can catch it and bite our tail from time to time, but that's about as far as we get. And so I really believe in an approach that expands our horizons outward to look at all the different aspects of our lives that are connected together. And I have an exercise I give to audiences like this. When I ask the people in the audience to imagine a place in which there's poor health and to actually pick a spot on the globe and close your eyes and think of an actual locale. And then I'd say, okay, you've gotten that place. Now, what are the quality of the roads in the place that you're looking? And what is the quality of the water? And what is the status of women in society? What about personal security? What about the economy? What about the quality of the air? And all of those things together are really markers of the Human Development Index and the status that everyone's living in. So I think that as we look broadly and realize that everything we do affects everything else that we're doing, we need to, that gives us the best chance of really reversing the trend of degrading the earth and making the future a lot more like the past that we admired.
Let's make
All right, one short comment. We're going to have to end. Yes.
I'd just like to add to that I think that as we increase our awareness about our individual health and take more control over it, we're going to become aware that our individual health is deeply intertwined with the health of our planet. And not just in a philosophical way, which is also interesting, but also in a deep scientific way, whether it's water, food, environment. These things are directly correlated. And that higher awareness of taking control over our own health will also mean taking control over the planet's health.
I apologize to those of you standing up. We've run over already, and so I have to end the session. Let's thank the speakers for their presentations. Thank you. I'm going back on Friday, but I'm going to Tokyo tomorrow.